Hello and welcome back to another video. In this problem, we're asked to prove that the limit as x approaches 0 from the right of ln of x is equal to negative infinity. So in order to solve this, we're going to have to use two different definitions from our textbook. The first is the definition of a right-hand limit, which states that the limit as x approaches a from the right of f of x is equal to L if for every epsilon greater than 0, there is a delta greater than 0, such that if a is less than x is less than a plus delta, then the absolute value of f of x minus L is less than epsilon. So the way in which we are going to do this is we have to compare this to the definition of an infinite limit, which states that the limit as x approaches a of f of x is equal to negative infinity if for every negative number n, there is a positive delta such that if 0 is less than the absolute value of x minus a is less than delta, then f of x is less than n. And so the way we do this is we look at, first of all, the infinite limit, since that's what we're actually dealing with. And we say, okay, if we have 0 is less than the absolute value of x minus a is less than delta, first of all, we say that the absolute value of x minus a is greater than 0. What does this actually mean? This means that x minus a is not equal to 0, since we already exclude negative numbers by the fact that it's an absolute value, and therefore x is not equal to a. Therefore, if we exclude this, we have x minus a, absolute value is less than delta. This means that it's less than delta and greater than negative delta. Therefore, x is less than a plus delta, and it's greater than a minus delta, right? It's adding a to all of these to simplify the inequality. So x is between a minus delta and a plus delta as long as x is not equal to a, right? So we can see this as a minus delta up to a, not inclusive, and then from a to a plus delta. And what this is basically saying is that if this is true over this range and this range, then this is true. And we can think of this as the left-hand limit and this as the right-hand limit. Therefore, if we're only looking at the right-hand limit, we only have to look between a and a plus delta. So a is less than x is less than a plus delta, which we can see here with the right-hand limit of a normal limit. This is the restricted values of x. So here, a is the value which x is approaching, so that's 0. So 0 is less than x is less than 0 plus delta, right? We can see that this is true if 0 is less than x is less than delta. Again, we are not looking at values less than 0 anyway, so we can just simply say that x is less than delta. If this is true, then f of x is less than n. And f of x here is ln of x. ln of x is less than n. ln is log base e of x is less than n. And therefore, undoing the logarithm into an exponential, we can get that x is less than e to the n. If you know how to convert a log to an exponent, but you're just not sure which one to keep on which side of the inequality, just keep x on the same side, right? So log base e of x is less than, therefore x is less than e to the n. Therefore, if x is less than delta and x is less than e to the n, we have delta is equal to e to the n. And since we have a relationship between delta and n, there is a delta for every n, and therefore the limit as x approaches 0 from the right of ln of x is equal to negative infinity.